class here to walk you through kind of a more challenging separation of variable problems from differential equations. For those of you using the book, I'm using the edition that's one edition back, but this is problem 10 in section 2.2. So this is my given differential equation, dy over dx equals quantity 2y plus 3 over 4x plus 5 all squared. So when we look at this, we're not able to just move the dx over right away, so I can get my y's on one side, x's on the other, because I have my y's and x's on one side, and they're not easy to move around because they're being squared. So first things first that I want to do here is I want to take care of that square. So we're going to apply it to both the numerator and the denominator. So we will have dy over dx equals, and then we'll say this is 2y plus 3 squared. Oh, let's make that a little clearer. It's going to be squared over 4x plus 5 squared as well. So then I want to move these to their appropriate sides. So I have my dy in the numerator on the left, which means that I want to get my y term of 2y plus 3 squared over to that side, but it's going to go on in the denominator, so I'm going to have to divide that over. And then likewise, I'm going to have to take this dx and multiply it to the other side, which will put it in the numerator, leaving this 4x plus 5 squared in the denominator. So it'll look something like this. We'll have 1 over 2y plus 3 squared dy equals 1 over 4x plus 5 squared dx. So now I have my y terms on the left, my x terms on the right. That's kind of our first step with the separation of variables problem. But again, I can't just do a simple, straightforward integral because these aren't kind of the more elementary, basic antiderivatives we could solve. So looking at this, we kind of got to think, what can I do? Because I know that, let me change my colors. I know that what I want to do next is apply the integral here and apply the integral there. So kind of got to think about what do I have to do? And what we remember is from Calc 2, or whenever you learned about integrals and how to solve them, is if I can't just solve the integral by looking at it and just kind of remembering what the antiderivative would be, the very first thing you should probably try is a u sub, right? So I look at this, and yes, I could u sub this. So I see on the left here that this u sub in the bottom could be u equals 2y plus 3. And maybe that feels a little weird for you because I'm putting a y into a u sub, but we just kind of got to remember that the y at this immediate moment is my variable, so it's going to act no differently than the x would over on this side. But I need to kind of keep these two separate, so this u is only going to apply to kind of my left-hand side here. So I say that u equals 2y plus 3, which means that my du is going to be, du is going to be, come on, 2 dy. So then I will say that 1/2 du equals dy. Equals are getting all messed up. Just redo that. 1/2 du equals dy. So, and then let's kind of, I guess, get the substitution ready for the right-hand side. Following good math notation, because I'm doing a u sub right here for y's, I don't want to use the same variable twice, right? So I'm just going to pick my other favorite variable. I don't know, let's just say v. So I'm going to say that v equals, and on this side, very similar u sub, it's going to be 4x plus 5 means that dv, someday learn how to write an equal sign, dv equals 4 dx, which means that 1/4 dv equals dx. Let's change our color again. Let's go with blue. So, then going over here, plugging all those substitutions in, where I see my 2y plus 3, I'm going to put my u, and where I see my dy, I'm going to put a 1/2 du. So I'm going to have the integral of 1 over u squared du, and let's put that 1/2 right out here, since constants can just come outside the integration. And then that will be equals to the integral 1 over v squared dv, because that 1/4 is just coming right out here. And then this is an integral that maybe I like from experience, I look at this, I know how to solve it, but if I don't see it, kind of got to think through what to do. If this was a 1 over u, I could just call it the natural log of u, right? Because that would be the integral of 1 over u. And what I see a lot of people do in my sessions is they still see the 1 over u, and even though it's squared or has something with it, they immediately still call it natural log because they see the 1 over something, right? But that only applies when it is the linear term with u, or like a u plus 3 or something like that, where you can turn that into a natural log. When you have a squared here, right, you cannot use the natural log as the antiderivative. You need to change this into just a different way to express it. So instead of saying 1 over u squared, I'm going to say instead that this is 1/2 integral of u to the -2. And then likewise over here, I'm going to say that this is 1/4 v to the -2 dv, because this is an integral I know how to solve, right? I'm going to add 1 to the exponent, I'm going to divide by that new exponent. So this becomes 1/2 u to the -1 over -1. Technically there's a plus c here. I'm just going to call it plus c1 equals 1/4 v to the -1 over -1, over -1. And then same thing, technically there's a plus c here, we're going to call it plus c2. All right, and then we need to turn ourselves back into x's and y's, right? Because I can't have my final answer be in these substitutions. And I'm also going to take this negative exponent and move it down to the bottom as a positive exponent. So we'll have our -1/2 from taking this -1 and moving it here with the half, and then I'll be times 1 over, let's see, u was 2y plus 3 plus c equals, actually this is a good time to kind of talk about something else we're going to do here. We can do it all in one step. When I have my plus c1 here and my plus c2 here, these are both arbitrary constants, right? I don't know what they are. They're some number, right? So I don't really need to say it twice. If it's just some arbitrary number, I can just combine these on one side and just call it c, right? And that is the shorthand that a lot of books use and that we will use in future problems. I kind of wanted to show a point here that yes, they both have a plus c, but because they're both arbitrary, we combine them on the one side. Typically the side of the independent variable, which for us will be the x. So because my v was the sub for x, we're going to put it on the v side. So this will be a -1/4 times 1 over 4x plus 5, and then this will be our plus c side. And there we go. So -1/2 times the 1 over 2y plus 3 equals -1/4 times 1 over 4x plus 5 plus c will be our final answer. There are some times with separable equations where you want to get the dependent variable by itself, and if it's easy to do so, I suggest it. But in this case, while it is possible to get y by itself, it's going to result in like a pretty kind of like unnecessarily messy answer. So I would recommend probably leaving your final solution like this unless your teacher said otherwise. I hope you found this video helpful. We'll see you next time.